Hi everyone, so you've already seen a video on how to factor, but I wanted to make a video on how to solve quadratics using factoring. So here we have 4 equations we're going to solve, and the method we're going to use is factoring. So if you look at example 1, we have x squared plus 12x plus 20 equals 0. Now our first step is always to make sure that the equation is set equal to 0, and in this case the equation is already set equal to 0, so we don't need to do any extra work for that. Now we need to go ahead and think about how we factor. When we're factoring, we're trying to find what two numbers multiply to C and add to B. So in this case, we're finding out what numbers multiply to 20 and add to 12. And this is not a method I did in class, but it is a way you can organize your work if it helps. So I'm looking for two numbers that multiply to 20 and add to 12. So I usually start by listing my factors of 20 if I'm not sure off the top of my head. So I've got 1 times 20. I always start with that one. 1 times the number itself. We've got 2 times 10. 3 doesn't go into 20. And then I've got 4 times 5. So those are all my factors. And then I need to figure out which of these add to 12. Now, we don't have to worry about the signs really because we're trying to multiply to a positive and add to a positive. So that means both of the numbers we choose are going to be positive. So our factors are good the way they are. 1 plus 20 would add to 21. 2 and 10 would add to 12, and then 4 and 5 would add to 9. So 2 and 10 are going to be the factors I choose because they add up to 12. So this helps me to rewrite the quadratic side of the equation as two binomials. So I'm going to write x plus 2 times x plus 10 equals 0. Don't forget the equals 0 because remember we're trying to solve this equation. Now that I have two things being multiplied equal to 0, I can apply my zero product property. The zero product property just means that when I have two things being multiplied set equal to 0, in order to solve this, I want to find out when each of these factors is equal to 0. Because when x plus 2 is 0, 0 times whatever, it doesn't matter what x plus 10 would be, as long as x plus 2 is equal to 0, 0 times anything would give me 0. And then the same thing applies for the other factor. Whenever x plus 10 is equal to 0, 0 times whatever x plus 2 is going to give me 0. So I'm going to set both of my factors equal to 0 in order to solve this. So x plus 2 equals 0. Let me get a new color. Or x plus 10 equals 0. And solving these two equations will give me my two solutions. So of course, to solve this, I need to subtract 2 from this equation. That gives me the solution of x equals -2. And then subtract 10 from this equation. That gives me the solution of x equals -10. So my two solutions, my two real solutions for this equation is x equals -2 and x equals -10. So remember, we want to use factoring whenever we see that the equation is already written in standard form, where you see the x squared, the x, and the constant. That's how you know you want to use factoring. So in example 2, it looks like standard form, but then I also have some terms on the right side. It's not set equal to 0. I have x squared plus 15x plus 40 equals 2x plus 4. So my first step here is going to be I need to get it set equal to 0. I want the 0 on the right side since x squared is already on the left. That means I need to move 2x and 4 over to the left side. So since they're both positive, I'm going to subtract 2x and subtract 4. And then I'm going to when I do this on the left side, I'm going to line it up with its like term. So 2x would be subtracted from 15x because they both have 1x. And 4 would be subtracted from 40 since they're both constants. So that will give me x squared plus 13x, when I subtract the 2x, plus 36 equals 0. Now I'm ready to factor. Now that I have it set equal to 0, I know what I'm trying to multiply to and what I'm trying to add to. So I'm multiplying to 36, always multiplying to the constant, and I'm adding to 13. So I'm going to list all my factors of 36, 1 and 36. It's even, so I know 2 is going to go in. If you need a calculator, you can always do 36 divided by 2 in a calculator. That would give me 18, I believe. Yep. And then we have 3 goes in. 3 times 12 gives me 36. 4 times 9 gives me 36. Does 5 go in? No. 6 and 6. And now those are all of our factors. So I need to figure out which one adds a 13. Once again, we got lucky for this one because we're trying to multiply and add to a positive. So both my numbers are going to be positive. I don't need to worry about putting any negatives in. So which of these would add to 13? 1 and 36 would add to 37. 2 and 18 would add to 20. 3 and 12 would add to 15. 4 and 9 would add to 13. 6 and 6 would add to 12. So 4 and 9 are my factors because they add up to 13. So now I have my equation x plus 4 times x plus 9 equals 0. Since they're both positive, they're both pluses in the two factors. Now we proceed the same way we did before. We're going to set each factor equal to 0. So x plus 4 equal to 0. And x plus 9 equal to 0. And then my last step is just to subtract in both equations. So subtract 4 to get x equals negative 4, and subtract 9 in this one to get x equals negative 9. So our two solutions are x equals negative 4 and x equals negative 9. All right. Now example 3 looks a little different. As you can see, we have this number in front of the x squared besides 1. Normally we've only had a coefficient of 1. Now we have a coefficient that's bigger than 1. So in this case we have a 6 in front. We've got 6x squared plus x plus 1 equals 6x. So before we even deal with that coefficient, we don't have it set equal to 0. That's a problem. So that's always my first step. Get it set equal to 0. So I need to move the 6x by subtracting it, and I'm putting it under the x because that's the like term. So now I have 6x squared minus 5x. Remember, this is like a 1x minus 6x plus 1 equals 0. All right, now I can deal with what I need to do because there's a 6 in front. So this adds a little extra step into our factoring process. Now our first step is, instead of going straight to figuring out what multiplies to 1 and adds to negative 5, I actually need to take my coefficient in the front, 6, and my number at the end, 1, I need to multiply them, okay? And that's going to give me the number I need to multiply to when I write my factors. So 6 times 1 gives me 6. So I'm actually going to be looking for two numbers that multiply to 6 and add to negative 5. So it's really important that you remember that step. If you're trying to multiply to 1 and add to negative 5, you're not going to find any numbers that work. You need to first multiply that number in the front, 6, with the number in the back, 1, a, and also think of them as the numbers a and c in standard form. We multiply a times c, it gives us 6, so we're multiplying to 6 and adding negative 5. Now I've got a negative here. We'll come to that in a second. Let's first figure out what multiplies to 6, and then we'll figure out how we need to change our signs. So my factors of 6 are, that keeps happening. I don't want the ruler. 1 times 6 and 2 times 3. We should know those without a calculator. Now, since I'm trying to multiply to a positive and add to a negative, I'm going to need both my numbers to be negative, because two negatives also multiply to a positive. When we're multiplying to a positive, remember, we can either do positive times positive is a positive, or a negative times a negative is a positive. And since we're adding to a negative, we need to choose the negative and negative option. So which of these would add to negative 5? Well, negative 1 and negative 6 would add to negative 7. Negative 2 and negative 3 would add to negative 5. So that's going to be the numbers I choose. Now, don't forget we have that 6 in front. So this is going to also alter our next step a little bit. Normally, we would just write x minus 2 and x minus 3. But then if I were to multiply everything out, I'd be getting x squared without the 6 in front. I'd be getting x squared minus 5x. But I wouldn't get the 6 in front. So like if I just write x minus 2, x minus 3, if you were to do your foiling or your double distributing, the x and the x would multiply to x squared, but we need it to multiply to 6x squared. That's what I'm trying to say. So we're not really sure where should the 6 go? What number should go in front of x to give us the 6x squared? There's obviously a couple ways it could go. We could have a 1 and a 6, a 1x and a 6x multiplied to 6x squared, or we could have a 2x and a 3x multiplied to 6x squared, but it's unclear which one to choose. So here's how we do it. We're going to put a 6 in front of both to start. Now, obviously, that's not our final answer. I forgot to make room for my equals 0. That's obviously not going to be our final answer because 6x times 6x would give us 36x squared, which is too big. We're just putting both 6's there as a placeholder. Now what we do is we say, okay, we need to divide out the greatest common factor in each of the two factors. So with 6 and 2, I'm thinking, what's the greatest common factor of 6 and 2? Or in other words, what's the biggest number that goes into 2 and 6 evenly? And that would be 2 because 6 is even, so 2 goes into 6 and 2 also goes into 2. So we're going to divide out a 2 there, and then same thing over here. I'm thinking, what's the greatest common factor that goes into 6 and 3? That would be 3 because 3 goes into 3 and 6. So you divide out the greatest common factor, and now it's going to give us the equation we want. So 2, when I divide 6x minus 2 by 2, I'm taking 6x, dividing it by 2, which gives me 3x. 2 divided by 2 gives me 1, so now I have 3x minus 1. When I divide 6x by 3, I get 2x, and 3 divided by 3 gives me 1. So now, if I'm multiplying 3x times 2x, that does give me 6x squared. It doesn't give me too much or too little. So that is our final equation. Now, of course, we're solving, so we still have our last step of setting each of these equal to 0. So I'm going to set 3x minus 1 equal to 0 and 2x minus 1 equal to 0. These have a little more work to solve. You got to add and then divide. So if I add 1 on both sides, I get 3x equals 1. And then I divide by 3, I get x equals 1/3 as one of my solutions. And then here I have to add 1 on both sides, 2x equals 1. Then divide by 2, so I get x equals 1/2. Sorry, just want to fix my color, so I'll give you a second to... Oop. All right, so we're going to have to do that again for the next one because you can see it has a 5 in front of the x squared. So our first step, so we have 5x squared minus 7x equals negative 6x plus 4. So of course our first step is we need to get it set equal to 0. So I'm going to move the negative 6x by adding 6x on both sides. And then I'm going to move the 4 by subtracting 4. And you can see there's not a constant to subtract from except 0. So it's just the negative 4 will just be added over to the left side. So now I have 5x squared. The negative 7x plus 6x gives me negative 1x. And then the minus 4 is over here now. And then we have it equal to 0. Now, once again, I've got a coefficient in the front, 5. So my next step, can't forget, is to multiply the first and last number. So 5 times negative 4 gives me negative 20. So that means I'm going to be multiplying to negative 20 and adding to negative 1. Sometimes people aren't sure what this number is because they just see the minus. If you don't see a number in front of x, it's a 1. So we are multiplying to negative 20, adding to negative 1. So I'm going to come up with factors for 20. I'm not going to do the signs yet. I'm going to do that after I come up with my factors for 20. So I have 1 times 20, 2 times 10, and 4 times 5. We did those on example 1 also. And then now I'm going to figure out my sign. So I'm trying to multiply to a negative and add to a negative. So if I'm multiplying to a negative, it's got to be 1 positive and 1 negative gives me a negative. So I need to pick which ones should be negative. Well, before I do that, I kind of need to know which factors I'm using. So whenever I'm doing one like this where I have a positive, I know one's going to be positive and one's going to be negative. Instead of adding the factors to see which one adds to one, I'm going to try and figure out which set has a difference of 1 because it's going to end up being subtraction that we do when one is positive and one is negative. So like 1 and 20 have a difference of 19, so that doesn't work. 2 and 10 have a difference of 8, so that doesn't work. 4 and 5 have a difference of 1, so that's going to be what I pick. But now I need to figure out which is positive and which is negative. If I'm trying to add to a negative, so add to -1, the bigger one needs to be negative. So 5 is going to be negative and 4 is going to be positive. -5 plus 4 does give me -1. So now don't forget, since we had that 5 at the beginning, we're going to put a 5x in front of both factors. And then we're going to use our greatest common factors to divide out and figure out what the correct equation is. So like right now our equation would be giving us 25x squared, which we don't want. We want 5x squared. So with 5 and 4, well, 4 doesn't go into 5, 2 doesn't go into 5. So there's actually not anything bigger than 1 that goes into both of these. So we're just going to divide it by 1, which means that factor is going to stay the same. Now with 5 and 5, 5 goes into both. So we're going to divide those by 5. So when I divide by 1, it stays the same. So I still have 5x plus 4 as one of my factors. And then when I divide by 5, both of them become 1. So 5x divided by 5 is 1x, so just x, and 5 divided by 5 is 1. So now we have x minus 1 as our second factor. Last step is to set them both equal to 0. 5x plus 4 equals 0. X minus 1 equals 0. So for the one on the left, we have 2 steps. Subtract 4 on both sides. Divide by 5. X equals -4/5. That's one solution. And then on this one, I just need to add 1 on both sides. So I get x equals 1 as my other solution. Hopefully this helped you with solving by factoring. And let me know if you have any questions.